Hello and welcome to Algebra 2, Chapter 2.6, and today we're going to discuss linear inequalities in two variables. So linear inequality is one in the form ax plus by is less than c, where a and b both can't be 0, so you at least have to have one of the variables. And when you graph these, you graph them on a coordinate plane versus our number line we were graphing them on before. Also, when you graph these, your solution is going to be a range. So these are the ones where you graph the line and then you shade and you get this region of answers. And so a solution is any ordered pair that makes a true statement. Everything in this region is a solution. Okay, and that's where an inequality differs from an equation. So the first thing we want to do is just check to see whether an ordered pair is a solution. Just plug it in and check it. When you do this, I would always just suggest you work straight down. So here I'm just going to plug in x and y. And you're going to work straight down. You're not going to change anything to the other side. So it's going to be 12 minus 6. And I just keep that right-hand side. And that is 6. Is 6 greater than or equal to 8? No, so that is not a solution. And then if we try negative 2, negative 9, negative 8 plus 18, which would be 10. Okay, just work straight down. Is 10 greater than or equal to 8? Yes, so that point is a solution. And you could have multiple yeses or multiple no's depending on where they lie on the graph. So the next thing we want to do is graph these, and if you don't remember from when you've done these before, less than and greater than are going to be a dashed line, and then less than or equal to or greater than or equal to is going to be a solid line, and my suggestion is pick a test point to know where to shade. Now maybe not so much on this one, but that's where. Okay, so you can change the inequality to an equal sign, and you can consider this y equals 2. It graphs the same line. So y equals 2 is the line where every single y is 2, and that is this line, and it's going to be solid because it has an equal to part, and that's that equal to part, not that one, okay? And then this is going to graph all of the y's that are greater than 2. Well, that's just all these, so you're going to shade everything up here. There you go. So what about x is greater than negative 1? Well, this is the line where all the x's are negative 1, okay? That's the same line. And this is going to be a dashed line because there's no equal to part. So here's my dashed line, x equals negative 1. And I want to shade all of the x's that are greater than negative 1. So you're going to shade everything that is greater than negative 1. So those examples are fairly basic because they were just horizontal and vertical lines. So let's look at something that's not a horizontal or vertical line. You can graph this two ways. You can graph it using slope-intercept form, or you can graph it using your intercepts. It's in standard form now. So if you want to graph it using your intercepts, for your x-intercept, if y is 0, you'd have 4x equals 8, so x equals 2. So 2 is my x-intercept. My y-intercept, if x is 0, you're going to get 2y equals 8, which is y equals 4. Okay, this is going to be a solid line because we have equal to. So draw in that line. And then I need to know where to shade. So what I suggested was you pick a test point. So a good test point would be 0, 0. Your test point, you can choose any point at all as long as the line does not go through that point. So you can't pick any point on the line, but you can pick every point off the line. So if I pick 0, 0, I'm going to test it in my inequality. So I'm going to have 4 times 0 plus 2 times 0 is greater than or equal to 8, which is going to give me 0 is greater than or equal to 8. That is false. So where 0, 0 is false, and you shade then the entire other side of the line. So that would be my true side. All right, that's what I have for you for 2.6. Let me know if you have any questions, and have a great day.